Our team number is
57576,
and we are from
Clearwater, Florida.
My name is Bryce.
My name is Skylar.
My name is Eric. My name is Ian.
My name is Bryce.
And my name is Chris.
Judges, may we please begin?
You may.
Thank you, judges.
Thank you, judges.
One major challenge in ocean exploration is coral bleaching, caused by rising temperatures and UV exposure, which damages vital ecosystems we need to study and protect. This phenomenon is particularly concerning because it directly affects the health of coral reefs, which are crucial to maintaining biodiversity in marine environments. Our solution is Coral Sentry, a system of floating shading devices guided by AI-powered ROVs. This system will help reduce heat stress on corals, support long-term research, and ultimately make ocean exploration more sustainable and effective. By addressing coral bleaching, we aim to preserve these ecosystems for future generations to come.
We began this season by meeting with a member of Scuba International, who shared some of the challenges they faced with ocean exploration, particularly concerning the health of coral reefs. We then brainstormed these ideas as a team using Microsoft Whiteboard. Each member contributed by presenting ideas they found interesting and discussing their potential impact on ocean research. The team then collaborated to narrow down our focus, leading us to explore the coral bleaching issue as our primary research topic. We felt that this issue needed immediate attention, and we knew that we could develop a solution.
To dive deeper into our research, two team members dedicated an entire week to exploring through the most promising ideas that could impact ocean exploration. After presenting their findings, the team voted on the best course of action. Coral bleaching emerged as the most critical problem we could address, so we focused on developing a solution to help prevent coral bleaching. From there, we set our sights on creating a system that could help mitigate the bleaching process and support the health of the coral reefs over time.
Coral bleaching is a pressing issue that directly threatens the health of ocean ecosystems worldwide. Solving this problem could help preserve marine life, maintain biodiversity, and ultimately contribute to the overall health of our planet. By developing Coral Sentry, we believe that we can make a significant impact on this issue and help safeguard the future of coral reefs.
After researching coral bleaching and prevention methods, we consulted with several experts to validate our solution. Katie Cooper, the CEO of Scuba International, validated the significance of the problem. Shannon Dixon, a PhD biology student at the University of Ohio, gave us detailed information on how shading can help to prevent bleaching. And Bryce Schaefer, an aerospace engineer who refined our ROV and shading device designs. The NOAA talk provided the first teams inspired us to incorporate AI into our design.
Coral bleaching occurs when corals expel the symbiotic algae they rely on for energy due to environmental stress factors, such as temperature changes, pH fluctuations, and UV exposure. These stressors cause the corals to lose their vibrant color, leaving them vulnerable to disease and mortality. Corals are considered a keystone species because they support 25% of marine life. Without them, marine habitats will collapse, affecting everything from fish populations to coastal protection and tourism. The impact of coral bleaching is far-reaching, and addressing it is crucial to maintaining ocean health.
Our solution is to create an ROV that works in tandem with multiple large shading devices to cover expansive areas of coral reefs. These shading devices will float and slowly move across the reef, reducing heat stress on the coral. For the Kiribati Reef specifically, we estimate that it would take about 1,300 shading devices that measure 30 feet by 30 feet to cover the whole reef over a 12-hour period, with each chunk being shaded for about 3 hours. Even though this is a large-scale project, we're going to start with about 100 shading devices and 25 ROVs. The ROVs could be either fully automated or controlled manually depending on specific needs and conditions.
To prototype our ROV, we used PVC piping to construct a model that could withstand the harsh conditions of the ocean. The ROV features motors, both back and forth with vertical movement, as well as 2 cameras to integrate AI for coral identification. It also includes a waterproof box in the back for weight distribution and electronics, ensuring stability in the water. Additionally, we used Blender to design a rough model of the shading device and then animated the devices in Unity to better visualize the movement and interaction with the reef. Here it is in action.
We expect our ROV and shading devices to endure harsh conditions over time, so we decided to use high-quality materials and protective coatings to ensure longevity. Sensors will monitor key components such as temperature and moisture levels to prevent overheating and other issues. In the event of a problem, the system's GPS will guide a technician for repairs. The shading devices are equipped with inflatable floats to provide buoyancy and stability, and the flexible arms will allow them to adjust slightly to changing water conditions. We've designed 3 sizes for the shading devices: 7.5 feet, 15 feet, and 30 feet, for flexibility across different reef conditions.
The total cost of building one ROV is approximately $4,026. The breakdown is as follows. $2,100 for lens wipers, $600 for motors, $200 for cameras, $150 for the battery, and $976 for the GPS, sensors, wiring, and an extra computer.
The shading device costs around $4,260. This breakdown includes $805.08 for the flotation devices, $800 for the motors, $755 for the battery, $720 for the solar panels, and $1,179.68 for the cameras and the structure. The combined total for one ROV and one shading device is approximately $8,287.
For coral identification, we use YOLOv5, an AI model trained to identify objects and images. And in our case, it will help us recognize different coral species and assess their health. The current version of YOLOv5 is free, but a new version is coming out soon, which promises more features such as on-premise option and source code access. Additionally, we're investigating into the use of photomosaics, which would provide a comprehensive, long-term view of the coral reef's transformation over time.
We have contacted several organizations in support in funding this project, including SeaWorld, Quill Marine Aquarium, and Tampa Aquarium. Our strategy is to showcase the environmental impact of our solution through video demos and detailed models. We are also applying for grants and seeking any sponsors who are passionate about reef conservation.
Alongside these organizations, we contacted various companies to help with sourcing materials and getting advice on product designs. CEJN provided us with the SSMQC connection piece for linking the ROV to the shading device, allowing for both charging and data transfer. We also worked with Blue Robotics on a waterproof camera housing that integrates with ZebraTech's camera casings. This collaboration has been crucial in refining our design and ensuring the feasibility of our solution.
We plan to pilot this project at Cayo Torres Reef near Puerto Rico. This is perfect for our pilot project due to minimal human interference, significant sun, and an existing bleaching problem. This site provides an excellent testing ground for both our ROVs and our shading devices to test them in real-world conditions.
To safeguard the devices from being damaged by boats or unauthorized individuals, we'll use reflective materials that will make the shading devices highly visible. We'll also issue warnings through radios and mobile apps to alert boaters about the device's locations. These proactive measures will help protect the devices and keep our project safe.
Our system will also use cameras to monitor the area for potential violations. If someone enters a restricted zone, cameras will identify them, and in the future, we plan to implement a system that will issue fines for such infractions. This will help protect the coral reefs and ensure that the integrity of our project is maintained.
In the event of severe storms, the shading devices will have an automated system that can move them to designated safe zones, ensuring they are protected during unpredictable weather. This feature makes the system both adaptable and resilient, which is crucial for long-term success.
In summary, coral bleaching is a significant threat to marine environments and coastal ecosystems. Coral Sentry offers an innovative solution by combining AI-powered ROVs and scalable shading devices to protect coral conservation. We've consulted with experts, collaborated with organizations, and developed prototypes that we believe can make a meaningful impact on coral conservation.
Coral reefs are essential for ocean health, and with the help of technologies just like ours, we can ensure they continue to thrive for many generations to come. Coral Sentry is not just a concept, it's a practical solution to a growing problem. We're really excited to bring this project to life and make a lasting impact on the protection of coral reefs. Thank you, judges.